In this video, we're going to go over the basics of Venn diagrams and set operations. Let's get started. So to begin, we want to introduce the concept of a Venn diagram. So we can fill in our first blank with the word Venn, V-E-N-N. It's actually named after the mathematician John Venn. So a Venn diagram is used to display visually the relationship between multiple sets. We'll start off with just two sets, so we'll just have two circles in our square here, or in a rectangle rather. So consider two sets, A and B. We say that A and B are disjoint. You can fill in your second blank with me, disjoint. Another term that you might hear in a different textbook perhaps would be the term mutually exclusive. Has the same exact definition, they're synonyms, as disjoint. So we say that two sets are disjoint if they share no elements in common. So for example, let me draw a quick little Venn diagram here. Here's my rectangle. If I had one set A represented by this circle here, and one set B represented by this very separate, non-overlapping circle there, that would be the situation that I'm talking about here, where there's no overlapping or shared elements in common. So that's called a disjoint situation. The two sets are disjoint. However, most of the time, I'm going to go ahead and erase that for now. Most of the time, Venn diagrams are used when there is an overlap. In other words, when sets have elements that they share in common. So when two sets do in fact overlap, we always want to begin by filling in the region of that Venn diagram where the overlap takes place. So for example, if you look with me on your slide, you notice that in this situation, set T and set F do have something in common, it looks like, because the circles are in fact overlapping. So that's always where we would start our picture. Okay, our Venn diagram. We always start in the overlapping region. We have a name for that region. That is called the intersection. So this is our next blank to fill in. The intersection of two sets, A and B, is the overlapping part. It's the shared elements that they have in common. Okay, the set of shared elements they have in common. Now there is an important symbol, and if I were you, I would be making flashcards perhaps with the symbols and the definition. So when I think intersection, the symbol I'm thinking of in between the two sets is an upside down horseshoe, or it looks like a U, right? Upside down U. Some people think of that kind of like the capital letter A, so it kind of could be read, what do A and B have in common? Okay, so some people think of it almost like an A there. Well, this looks more like an A, but you get the idea, hopefully. What do A and B have in common? Okay, so let's take a look, for example, at our picture on the screen here. So here we notice a Venn diagram. Now, to be a proper Venn diagram, you should make your rectangle, but you should also use the letter U here, the usually capitalized or italicized. I probably should have made it italicized. That letter U stands for something. It stands for the universal set. That's our blank right here in the middle of our screen. The universal set of all elements basically gives the person the visualization of all elements under discussion. Now sometimes these could be people that we've sampled, right? This could be data points, but it's every possible element under discussion lives in your rectangle called the universal set. So inside of that universal set, notice there are two overlapping circles, set T and set F, okay? So if I were to begin by filling in this Venn diagram, where do we start? That's right, in the overlap. So let's take a look in this example. What would T intersect F be? Well, it's the set of all elements that are in both T and F. So let's look below at what the description here is for T and for F. It says T are the multiples of 2. And in this case, the multiples of 2 that we were talking about are the multiples of 2 from within the universal set above, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from those numbers in our universal set, which of them are multiples of 2? Well, 2, 4, 6, 8, and 10. So that would be what we call set T. Now before you start just drawing your Venn diagram and sticking 2, 4, 6, 8, 10, we want to be really careful that we start with the overlap. So in the overlap, we say, okay, what does T have in common with F? Well, F is the set of multiples of 4 from our universal set. So that means 4, 8. The next one would be, what? 4 times 3 is 12, right? But notice 12 is not in our universal set, so we'd only have 4 and 8 here. Okay, so looking at T and looking at F written in roster notation, we learned that in a previous video, which of those elements do they share in common? Yeah, it would be the numbers 4 and 8, right? So we notice that 4 and 8 are in the intersection, that's what this says here, the intersection of set T and set F. So that's actually where I would want to begin if I'm drawing a Venn diagram. I would put the 4 and the 8 inside that overlapping region. All right, but let's talk about another piece of notation that you're going to see frequently when you're talking about Venn diagrams and sets. And that is the word union. What do we mean by the word union? Well, we say that the set of all elements in A or B, or both, is called the union. And it is written with this symbol here, A union B. Now that union symbol kind of looks like the letter U, right? But it's actually more like a horseshoe. It's not the actual letter U. So that is the union symbol. That looks a little bit similar to the intersection symbol, but notice they're different. For intersection, to be in the intersection of two sets, you have to be in both of the sets. But to be in the union, as long as you're in one of them, you're in their union. I like to think of this, for example, and again, bear with my example, it might not work for everyone. But when I got married, my union with my husband, I got all of his debt, he got all of my debt. I got all of, if I had kids, his kids are now in the family, my kids are now in the family. If he had pets and I had pets, everything goes into the pot. That's called the union. The things that we already shared in common would be our intersection. I hope that makes a little bit more of a difference for you. You can see the distinction in definitions. All right, so let's get back to our picture then and see if we can write out the union for this example. So what would T union F be in this particular situation? In this particular situation, the union would be everything that T had, everything that F had, as well as anything that they shared together. Those are all going into the pot. That would be the union of T and F. So we're going to look at T, which was 2, 4, 6, 8, 10. We're going to look at F, which was 4 and 8, and put all of those in the pot. But keep in mind, we don't have to repeat elements. If we've already mentioned them once, then they're already there. So this would just be 2, 4, 6, 8, 10. Now notice there's nothing beyond set T because F was entirely consumed by T, wasn't it? They share those in common already. But sometimes F could have an extra element that T doesn't have, and that would also go in the union. Okay, so now that we know that, we could look at the picture a little bit more clearly. So we've already talked about what they have in common, the 4 and the 8, so that's where we start our picture. But what about elements which are only in T, but not in F? Do we see which elements those are? Let's see, only in T, but not in F. Well, T has a 2, 4 and 8 are in am I saying that right? No, T itself here, there we go. T has a 2, T has a 4 and an 8. It also has a 6 and a 10, okay? So the 2, the 6, and the 10 are unique to T. So I'm gonna put 2, I'm gonna put 6, I'm gonna put 10 right there. Now, does F have anything unique to itself besides what it shares with T? No. If it did, we could stick it in this region here, right? That's where it would go if F had any items unique. So in this situation, this would be something where maybe my husband didn't bring any money to the table, right? Or he didn't bring anything to the table. He just shared stuff with me. Hopefully that's not the case in your relationships. But all right, so this would be the situation. Now, in this universal set, keep in mind that there may be other elements that were not mentioned in T and F. Is that the case here? Well, let's take a look. The universal set, U, right here, this universal set, consisted of the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, were all of those elements found in T or F or both? No. In fact, all of the odd-numbered elements were not. So I could say 1 would be floating out here somewhere, 3 would be floating out here, 5, 7, and 9. All of those elements are in my universe, but they don't nicely belong to the category of T or F or both, right? So this would be an example of how I'd go about drawing that Venn diagram if I already know which elements are in which set and which elements are in my universe. Now there's one other piece of notation that I want to mention before we head to our next slide, and that is called the complement. Now again, the complement is the English word here. Let me point it out to you. Get another color I haven't used. How about brown? Okay, so the complement. Now, usually spelling is not something that math people pay attention to, but in this context, it might be helpful if you do pay attention to how this word is spelled, okay? So it's not the word complement with an I, but complement with an E. The reason I think that's helpful is that if you take a look at the first, I think it's 6 letters, C-O-M-P-L-E, okay? That is also how you start out spelling the word complete, okay? So when I'm talking about the complement in this math concept for set theory, what I'm saying is, which elements are missing from my current set that are in my universe and would be necessary to complete the universal set. So for example, if I were to write, what is T complement? Okay, let's take a look at our picture here. To get T complement, we would say which elements are in the universe that T does not currently possess, that if I added them to the complement, I would complete the universal set. So I look at T, and all of the elements that are found in T were 2, 4, 6, 8, and 10. Basically, which elements is it missing? Well, it would be missing all of these elements that are outside of T. And it would also be missing anything that happened to be an F here alone by themselves. So in this case, I would say 1, 3, 5, 7, and 9. That would be the set which would complete the universal set, right? It would give everything that T did not already have from the universe. What about F complement? Can we think of what F complement might be? I'll go up here, right above my head. There we go. Yeah, what would F complement be? Try to pause the video and write down what you think F complement is. Okay, let's see how you did. So it would be everything in the universe that F does not already have. So what does F possess? Which elements? It possesses 4 and 8. Okay, so it is missing all of the rest from the universal set, which would be 1, 2, 3. It already has 4, so we don't need that, but it would be missing 5, 6, 7. It already has 8, so no need to add that. And it's missing 9, and it's missing 10. So this would be what we call F complement. So I would really encourage you to take a moment on this slide, make sure you have your note cards, your definitions clearly labeled. Practice until you really understand the difference between each symbol, the complement symbol versus the intersection and the union, because in our next slide, we're going to put all of this to practice. Okay, here comes the example. Like I said, we're putting it to practice. Example 1 says, find using a Venn diagram. Okay. So sometimes, like in our previous slide, they give you the sets themselves directly. Other times, they give you the Venn diagram, and you need to use that to answer the question. So let's take a look at this Venn diagram. Notice this is more complicated. We have 3 sets under discussion in our universe. Now, technically, to be proper, if you were making your own, you would want to put a universal U in the corner somewhere. That tells the reader that everything in this rectangle is our universal set. So if I were you as a student, I would probably begin by trying to write out which elements are in which set. So for example, let's start with set A. Which elements do we see in set A here? In set A, I see the 1, the 3, the 2, the 4, and the 9. In order, that's 1, 2, 3, 4, 9. 1, 2, 3, 4, 9. I'm writing these in roster notation like we learned in a previous video. Okay. What about set B? Let's take a look at set B here. So in set B, that's this one, which elements do we see there? That's right, 1, 3, 5, and 8. 1, 3, 5, and 8. Now you might be thinking, Professor, do we really have to write all these out? Can't we just look at the picture? Yes, you can, but I think it's helpful to have both side by side. The sets themselves written out just in case you look too quickly at the picture, as well as the Venn diagram to visualize what's going on. And what about part C, or set C rather? So set C would be the 2, the 3, and the 7, wouldn't it? Now the universal set, actually I'll use a different color here. For our universal set, which elements go inside of that? Do you remember from our previous slide? That's right, it's everything under discussion. So it would include all elements inside each of the 3 circles, as well as any elements that are in the rectangle floating out there. So that would include the 6, for example. He would also be in the universal set. So I would need to have 1, 2, 3. There is a 4, isn't there? Yep, 4. There is a 5. Is there a 6? Yep, that's floating outside in the rectangle. There is a 7. There is an 8, and there is a 9. I don't see a 10 anywhere. So that would be my universal set with those 9 elements. With that in mind, let's see if we can answer our first question. It says, find A complement. Remember, that's what this symbol means here, that apostrophe after the A. Find A complement union B complement. So when you're starting out, the order in which you do things is really important, okay? So whenever you see a complement right next to a letter, you want to take care of that first. I might make a note in my notes right now. If I see a complement symbol right next to a set letter, I'm going to find that first. Okay, so let's go ahead and find A complement. So to do that here, to find A complement, we already know what A is, right? We can look at the picture of the Venn diagram. So to find A complement, it would be everything that would complete the universal set that A does not already have. So we say, okay, the universal set has a 1, A already has that. It has a 2, A already has that. It has a 3, A already has that. It has a 4, A already has that. Ooh, what is A missing here? That's right, it's missing a 5. So I'm going to make a new set for my A complement. 5 would be an A complement. What else is A missing from the universal set? Is it missing 6? Yeah, it is. It's missing a 6. 7 and 8 as well. Is it missing 9? No, it has the 9, doesn't it? So this would be the set A complement, the set with 5, 6, 7, and 8, because those are the elements that A was missing in order to complete the universal set. We're going to unite that with B complement. So let's go ahead and find B complement now. See if you can pause the video and find it yourself, just like we found A complement. Okay, let's see how you did. So from the universal set, we already had the 1, B has the 1, but B was missing the 2, wasn't it? So B complement should have a 2 in it. And from the universal set, we already had the 3, so that's great. But B was missing the 4, so we'll put that in our B complement set. B is missing the 5. Was that correct? No, that's incorrect. B is not missing the 5. B has the 5. B is missing the 6, so I'm going to put that in my complement. B is missing my 7, so that goes in the complement. B appears to already have the 8, so we don't need to write that. But B is missing the 9. And again, you can check this with the Venn diagram as well, right? So you look at the B circle here, everything from the universe that's not here. So that would include 2, 4, 6, 7, and 9, wouldn't it? Okay. So now we're not quite done. We now understand who we're uniting. We are uniting A complement, that's this set here, with B complement, that's this set here. Notice we're not uniting A and B. We're uniting their complements. So how do we unite two sets? Which elements are in their union? Feel free to go back to your notes if it's still rusty and new. That's right, it's everything from both categories, right? We put everything in their union together. So the answer here, let me get a little bit of space for us. When we unite these two, we get, I'm going to come on down, we would get 5, 6, 7, 8 along with 2, 4, 6, 7, 9. So if we put those in order, the smallest number in these two sets is the 2, followed by the 4. Feel free to cross them off as you go if that helps. The 5, the 6, remember we don't have to write them twice. Once is sufficient, it makes its appearance. The 7 was in both of them. The 8 was only in the first one. And then the 9. Okay, so this would be the union of the complements of A and B. Okay, so that would be the first answer. Okay, so that is how we take care of a situation where we have a complement right next to a letter. Now notice in part B, however, this time we're dealing with something a little different. Here we have parentheses. So just like in your algebra classes, we usually want to do what's in parentheses first. So we go inside parentheses, and now you ask yourself, are there any complements I need to talk about? For example, is there an apostrophe next to A or B? No? Okay, then go ahead and proceed. So we proceed by taking the, what does this mean? Yeah, that's right, the intersection of A and B. So I'm going to come down here for this problem here. So what would the intersection of A and B be? So if I look at A and I look at B and I want to find their intersection, what did that mean again? Yeah, the elements that they share in common. Feel free to look at the Venn diagram as well. It might be easier to see that way. What do A and B share in common? If you said 1 and 3, that's what this picture shows, right? Here's 1 and here's 3. You can see clearly they are sharing those in common, A and B. They also share the 3 with C, but right now we're just interested in what do A and B share. And you can also see that from the actual sets in roster notation, right? They share the 1, they share the 3, okay? So I would put parentheses, and then I write my set. In fact, the parentheses aren't as necessary now because I've already done the operation, so I'm going to apologize, erase the parentheses. I'm going to open up the set, and here comes the intersection of A and B. It would just be the set containing 1 and 3. Okay. Now you've taken care of the first part. You've done the intersection of A and B. Next up, we are going to take the union of that set with set C. Now, does it say C complement or the regular set C? Yep, the regular set C, so that's this one here. Okay, so set C had 2, 3, and 7. I'll just copy and paste it. 2, 3, and 7. Okay. So at this point, we are supposed to unite them. Now remember, the union is different than the intersection. If this was the intersection, it would just be what do they share in common, which would be just the set with 3 inside. Now remember, it is possible that 2 sets can share nothing in common. They're disjoint. In that case, we would say the answer is the empty set, or the circle with the line through it. But in this case, they do have an intersection, and that would be the set containing 3. But since it's not asking for the intersection, it's asking for the union, this answer would be what? Yep, take everything and put it in the pot. That's right. 1, 2, 3, and 7. That would be the union of the intersection of A and B with set C. Okay. Now I'm going to go ahead and take a moment here and erase what we've done so far, so make sure you have it in your notes as we head over to C and D. Big eraser here. Here we go. Okay, so take a look at what we're going to be doing for C and D. And think about what we've talked about already. We've mentioned doing complements first if it's next to a letter. We've also mentioned doing parentheses first. So as you look at C, try not to get overwhelmed by the complement and the parentheses, but just tell yourself, if I see a complement, I take care of that first. If I see parentheses, that's going to be the first priority as well. So let's see how we would basically triage this one here. So we're looking at problem C here. Let me get a color you'll see for me. Okay. And it says, I would like you to take, now what is the outside piece? That's a complement. So I would like you to take the complement of what's in parentheses. In parentheses, we have the intersection of B and C. So before we can take the complement of something in parentheses, we need to take care of the parentheses, don't we? So if you're trying to triage what to do first here, you take care of the inside of the parentheses and then the outside complement. So make sure you write that in your notes if you need to. So let's do the intersection of B and C, shall we? The intersection of B and C. So what does intersection mean again? Feel free to check your notes. That's right, what do they share in common? So I could look at my Venn diagram, maybe that'll be easy to see. Here is set B, here is set C. Do they share anything in common in their overlap here? If you said they share 3, that would be correct. And you could also see that by just looking at the sets themselves in roster notation. Here is the 3 that they share, right? So this part would just be the set with a 3 inside. And again, sometimes it's an empty set if they share nothing in common, but in this case there is one element. And now we're asked to take the, that's right, complement of that set. So what does that mean? If I'm taking the complement of set 3, a set with 3 inside, that would mean I go to my universal set and ask myself, what am I missing to complete it? So I'm missing everything except for 3, aren't I? So this would be go to the universal set and write everything except for what I already have. So what do I need to complete the universal set? Everything besides 3. So 1, 2, 4, 5, 6, 7, 8, 9. Okay. So again, that can be intimidating, but what we did is we started in the parentheses, we found the intersection of B and C first, which gave us the set with a 3 inside, and then we found the complement of the parenthesis. So that's the order in which we do things when we have the parentheses there. Okay, let's see if you can try D on your own. Pause the video, come back, and check your work. Okay, let's see how you did. In D, we're supposed to take the intersection of A and B complement. So the first part, remember what we talked about? We always take care of the complements first. So you can go ahead and write down your complement here. We actually found that earlier, so if you have your notes, feel free to look back to part A, because we already found B complement. You can save some time in a problem if you notice that. What was B complement? It was everything that was not in B that would be needed to complete the universal set, right? So in that situation, B complement, this guy, he was not 1, but 2, not 3, but 4, not 5, but 6, 7, not 8, but 9. That, I believe, is what we had for B complement. Everything from the universal set that was missing from B. So we are supposed to intersect that with set A. Let's take a look at set A here. So what is set A here? Set A was 1, 2, 3, 4, 9. Let's see if I can squeeze that in. 1, 2, 3, 4, and 9. So if I'm going to intersect those two, what does that mean? How did you do it? Did you find what they had in common? I hope so. Let's see what your answer was then. So did they share 1 in common? No, so 1 would not be in the intersection. Did they share 2 in common? Yes. So 2 is in their intersection. Did they share a 3? No. Did they share a 4? Yep, there's our 4 that they shared. Did they share a 9? Yes, they did. Obviously, then you can tell they didn't share the 6 or the 7 that this set had, okay? So this would be our answer here. 2, 4, and 9 would be inside the set of A intersect B complement. Okay, again, this was a heavy-duty example, so I would really recommend that you pause it, you go ahead and work it yourself for every single case, and make sure you understand or reach out if you have questions. Let's head over to our next slide when you're ready. So one more piece of notation that we want to talk about in this set is the idea of a set difference. Okay, so consider the fact that you have 2 overlapping sets like we have here in the picture, set A and set B. So there are some shared elements in the intersection. There's also some elements floating around in the universe. We would say that we have the set difference, so that's our blank here, written A minus B. If we're talking about every element which is in A, so in our first set, but not in B. But not in B. So what some people read this as when they see set A minus set B is take every element of A and then subtract any element that was in B. So we take away or take out those which were shared in B. In other words, what this is really describing is those elements which are completely unique to A, not the ones that it shares with B. And you can see that in the picture here. So in the picture here, let me go ahead and write out our elements together. Let's see. So for set A, for example, which elements do we see here for set A? Using our Venn diagram. I see a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's set A. Okay. Now let's look at which element set B has. Set B, it contains 2, 4, 6, 8, 10, 12, 14, 16, 18. A lot of evens, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. So, and then the universal set contains all of those elements along with the ones that are floating around, right? Okay. So if I asked you to find A minus B without even looking at the Venn diagram, you could start off by taking a look at A and then taking out or deleting any elements that are found in B, because that's the order that this is written in, A minus B. But if it had said B minus A, we would have started with B and then removed any elements that were found or shared in A. So in this case, which elements would I be deleting, if you will, for A minus B? For A minus B, I would delete the 2 that they share in common. So I'm starting with A and deleting the elements from B. I would delete the 4 that they share in common. I would delete the 6 they share in common, the 8 they share in common, and I believe that's all. So the only elements that are unique to A, if you will, they're in A but not in B, would be the 1, 3, 5, 7, and 9. That would be A minus B. Now what I would recommend you do is pause the video and do it backwards, B minus A. So start in B and delete all the elements that are in A. You could also visually see this in the Venn diagram, right? Are these the elements which are in this region here, right? This shaded region? Yeah, those are 1, 3, 5, 7, and 9. Those are the elements which are unique to A that are not in B. Okay. The other piece of notation here to check out is a formula that is going to be really helpful going forward. And the formula is for the number of elements, so remember this N in front means the number of elements, or the cardinal number, of A union B. So what is that saying? It's the number of elements that are found in A or in B, or both, okay? So one way that you could figure this out is if you had all of the elements of A and you knew that. For example, here we've listed them. There's 1, 2, 3, 4, 5, 6, 7, 8. There are 9 elements that are found in A. We've also listed all the elements in B. 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. That's not always the case. So there's equal number of elements here. So we would call these equivalent sets from our previous videos. So if we know that, do you think the answer then is that there are 18 elements, 9 plus 9? So the number in A was 9. The number in B was 9. But that means we'd have 18 elements in their union. Well, does that make sense if they shared elements? Right, if they shared elements, haven't we double counted some of them? That's right, we have double counted some of them. We double counted their intersection, right? So we actually need to subtract those 4 elements that we double counted, which would produce the number 14. So 14 would be the number of elements in their union, okay? So what is the formula? The formula for the number of elements in A or B, get ready to write this in your notebook, is the number of elements in A, so n of A, plus the number of elements in B, minus the number of elements in their intersection, in the shared region. And how do we write that? A intersect, remember that symbol like this, the upside down union symbol, A intersect B. Okay, so how do you find the number of elements in A union B? Well, you add up the number of elements in each of the 2 sets uniquely, and then subtract any that were shared, so you don't double count. All right, so that's as far as notation, all that we have for you in this lesson. So let's do one more example now, putting this into practice. Here we go. Example 2. Find using the Venn diagram. So here again we have set A and set B, which something overlapping, some shared element in common. And again, to be precise, they should have a union symbol here. So this is the union that's under discussion, or the universal set, I should say. So let's take a look if you can answer the question, what is A minus B? So feel free to pause the video and see how well you understood the previous examples. All right, let's see how you did. A minus B would say everything in A, delete the B elements that they share in common. So it would just be these elements that are in A but are not in B, right? So that should be the elements 4, 6, and 8. Okay? You could have also written it out. Write everything out in A. That would include the number 2, wouldn't it? Write everything out in B, which would also include the number 2, and then delete the number 2 from A, since that is the one shared element. Okay, let's try the next one, see how you did. It said find the number of elements in A union B. Remember that formula? Well, you could use the formula, take the number of elements in A, add it to the number of elements in B, and subtract the number of elements that they shared in common, A intersect B. So how many elements are in A here? 1, 2, 3, 4. How many elements are in B? 1, 2, 3, 4. And how many elements were in their intersection? In other words, the overlapping region that they shared? Just the 1 element, right? So your answer here should be 8 minus 1, which is 7. Now you might be thinking, Professor, did I need the formula for that? I can just count 1, 2, 3, 4, 5, 6, 7. You are correct. However, when you get into higher level word problems and applications with lots more elements, this will be an important formula to save you time, I promise. So you gotta take my word on it for here. All right, B minus A. Pause the video if you haven't already done this problem, see if you can do it yourself. All right, let's see how you did. B minus A says everything in B that is not found in A. So in other words, these elements here, which are unique to B. So hopefully you said 3, 5, and 7. Now also I want to point out to you one distinction that some students struggle with, and I don't blame them because there's a lot of new concepts and notations coming at you. This is very different. B minus A and A minus B, very different than the complement, right? The complement would have included the 9, right? Because that would include everything that you're missing in order to make up the universal set, okay? So keep that in mind. Complement is very different than set difference. If you have any questions about any of the concepts that we talked about today, please don't hesitate to reach out to me. Otherwise, happy practicing, and I'll see you next time because math is not a spectator sport. Bye-bye.